No, I don't want to use that one. I'll use everybody has Excel or something like Excel on their laptops, yeah? Whatever you have, yeah. No spreadsheet program.
No, it got deleted my laptop.
How did it get deleted?
The laptop crashed.
Well, you'll just have to make notes for what we're doing then, okay? Okay. You have this open? Yes? It's like being in the cinema, isn't it? Now, first thing I want to say, lab number 3, that is Ohm's law. Remember? And in this lab, you do it like the other 2 labs, except you have a bigger analysis section. Are you all listening to me? Yes? Look at me, look at me, look at me, Mo, look at me. So this lab has a bigger analysis section, and it's very important that what I'm doing, you do too, but you must explain it in your lab as well. And the reason for that is, when you do lab reports or statistics reports, and if you use a computer program, you must explain to the reader how they can reproduce the results in the computer program. So for example, you would have to say, I am using Microsoft Excel 2008. Okay, so that is important. So I'm going to show you what to do, but if you need to make notes, you can open up Word or whatever to type notes as well. So the first thing we need is we're going to need some data. So if we all use the same numbers, that would be good. So let's just type in some data, X's and Y's. Okay, so 0, 1.1, 0.9, sorry, not 0.9, 1.9, 0, 1, 2, 3.2, 4, 4.9, 5.1, 6, 7, 7.9, 8.3. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3. Oh, so, well, okay. Right, and then here, 1, okay, so there's my X's and Y's. So I'd like you to type the same numbers in, please. Okay. Let's make it pretty. Okay. You got those numbers typed in? Yeah? Do you have those numbers? Yes? I want to make sure you're all with me, so I'm not going too fast and you miss a step. So can I go to the next part? No? Are you typing these in? Yes? Yes. Okay, so what I'm going to do first is I'm just going to draw the chart of it. Insert chart. just so we can picture it. Okay, scatter. Scatter. Keep going. Right, so title is just my graph for physics, whatever. X-axis, whatever it is. X units, whatever we use. We give both, we don't need that. Okay, we finish. Alright. Come on, move. I know, it looks bad, because my screen is so small. Oh, I guess that's not so bad. I'd like you to draw the graph too, yeah? This is scatter graph. And the reason I'm drawing the graph is to show you that it is nearly a straight line, but it's not perfectly a straight line. So make this graph, please, and I remind you the name of this graph is called a scatter graph. Do you have this? I'll give you a minute. We have plenty of time, okay, so we don't need to rush. It's very important that you understand all the steps here. Everybody will have a different program. Some will have LibreOffice, some will have OpenOffice, some will have Excel, Microsoft Excel. So I can't really show you how to do it for every program, but I hope you all can figure it out from your own. Do you all have the scatter plot now? Yeah? Okay, that's good. Now, what I'm going to do next, hang on, I have to click these points here. Come on. There we go. Oops. Now the next thing what I want to do is I want to put a straight line on my graph. Now you'll notice that these points are not a straight line. So we put the straight line that fits as best we can the points. And on the program this is called the trend line. So in my program I highlighted the points by double clicking them and I pick insert trend line and we pick linear, and we won't worry about this yet, but if these options are convenient for you, you should pick them. But if you don't see those options, don't worry, I just want the line right now. Some people will have a little plus sign here, maybe, and some people might have it in the menu up here. So I'll give you a minute to try and find it. This is called the trend line. So how many people have the trend line on their graph? You do, Ray, and Mohammed, Daniel, Dana, and Susan? Yeah. Do you have it on? Your laptop? Since when's your laptop broken? How long's it been broken now? And when are you going to get it fixed? Okay.
To use the Mac, yeah.
Do you have this, Tanish? Yeah? Okay. What's wrong? You're swapping places? Alright. Anyway. Okay. Let me just open up here. So I just want to draw something for you. Okay. So can you look? What we've done is we have a line, and not all the points are on the line. Some of them are off, some of them are on. This line in the program is called the trend line, but really its correct name is called the line of best fit. And it's the line that fits the points as much as possible. So you need these words, please. Line of best fit. Okay? This line is y equals mx plus c. So the question is, how do we find the m and how do we find the c? Well, in maths class, we will not do this. The business students, believe it or not, do it. We will just use Excel to calculate it for us. Excel will calculate the slope. So to calculate it, I go back here, I use this function. Whoops, come on. So this is the slope m equals slope, I think it's slope, bracket. Now, just be very careful. Look up before you do anything. Notice how in the slope function they want the y first and then the x next. Okay, so what I'll do is I'll highlight the y, colon, highlight the x, close bracket. So here I have slope B2 to B12, colon, A2, sorry, semicolon, A2 to A12. It's B and A, not A and B. Come on, Mo, is that important? No? Yes?
It's not enough arguments.
No, it means you're doing something wrong. Watch, I'll do it again. Tanish, watch closely. Equals, now I'll look up, equals slope, bracket, highlight the y's, semicolon, highlight the x's, bracket, enter. Some programs, listen please, some programs want you to use a comma instead of a semicolon. So maybe for your program, you need to have a comma here separating them.
Slope and...
There it is there. So I want to make sure, because remember, for Ohm's law, it's the slope that's really important, because the slope tells you what the resistance is. So have you calculated the slope of the line? Yeah? Where's your slope? Oh, that's right. Well, are you making notes about what I'm doing, the steps? No, I want to see like words like type in slope and all this stuff. Yes? What's wrong? I just told you. You're typing in the semicolon. No, stop pressing the button. You're typing in the semicolon, and I said some programs need a comma, and your program does need a comma. See, it says it right there. So listen to me, please. Have you done it?
Yes.
Yes? Okay. Okay, so if I just go back to my rough little sketch here, what do we have for the n? Well, it's roughly about 1.97, isn't it? Something like this. Did you get that now?
Yes.
Yes. Good. Okay. Next we need the c. So in a similar way, the c is called the intercept, c, and the function is equals intercept, comma, and again, sorry, not comma, intercept bracket, highlight the y's, semicolon, highlight the x's, bracket. Exactly the same as slope. Just replace the word slope with intercept. And you have it there. Yes.
Could you click on the intercept stuff?
The function, sorry, you can see it there. Have you calculated the intercept for me, the c? And did you get the same number? Yeah? Good, okay. Notice, look please, notice on my graph, the equation of the line is the same as what I calculated here. Can you see that? 1.97x plus 0.85. Yeah? Okay. The next number is r squared. Does anyone know what that is? It's called a correlation, and I'll explain what it is now. And the function is, I think it's CO or. No, is it CO or? Hang on, I'll have to get it open in the function button here. Oh, Corel, is it? C-O-R-E-L? O-R-E-L? Yes, there we go. So I can just highlight both of them. I think we'll do it. I think. I'm not sure. No, I have to do it the same way. Okay. Corel, bracket, yes? Okay, phone call?
Yeah.
Alright. Corel, y, semicolon, x, bracket. There we go. Same number, isn't it? Oh no, it's not quite the same. Oh yeah, sorry, I know why. This is correlation or equals. So it's just like slope and intercept, except we use Corel. And then finally, for this piece, we do correlation or squared. And that will just equal this number squared. So, do you know how to do square? I think it's this symbol with a 2. Hang on. Guys, can you look up for a moment? So here, equals this number multiplied by itself. So for me it's B16 multiplied B16. Now I get it here. Close. Hide. How do I... There we go. Okay. Do you have 989? Yep. Does anybody know what this correlation or squared means? Have you seen it before? You do? What is it? Very good, yeah. So if you look here, whoops. Which line is better? This one? Or this one? Well, of course it's this one. So this correlation R squared, it's a number between 0 and 1. Again, we don't have to worry about how to calculate it. The computer program calculates it. We need to worry about the meaning. This is the meaning. If R squared equals 0, we have this. And if R squared equals 1, we have this. Perfect. R squared will tell us how close the points on the line are. We want R squared to be near 1. This is good for us. So if I go back to my graph, what value of R squared do we have? 0.989, which is excellent. Will we ever get it as 1? I don't think so. It'll never perfectly be a line. But the nearer to 1, the better. So, why do we care about R squared? Well, the reason is this. You shouldn't say in a lab report, my graph is a good graph, or my graph is a bad graph, because words like good and bad, they're opinions, aren't they? They're not defined. But you can say, my graph correlation is nearly 1. That's not an opinion, that's a fact. And if it's nearly 1, it means it is good. And if it's nearly 0, it means it's very bad. Okay? So this is how you can make your report more scientific, more technical, less opinion. You can use things like correlation to describe your quality of your graph. Okay? So we're going on to the next part. Do you all have this? And you can see the numbers on the graph as well there. Oh, think back to chemistry. What do you think this point here is called? What was the cause of this point error here? Human error. There's something went wrong with the machine here, because this one is quite different, isn't it? This one here? Don't you agree that it's further away than the other points? So, human error, I think, was here. Do you remember the word I gave you when a point is really far away from the line? Like, for example, if I change this last one here. What's this point called? Do you remember the word I gave you for this point? Anybody? No? Outlier. Do you remember? Outlier. There we go. I need to delete this graph to make more space. Is there any questions about this graph? I don't think so, no. Can I delete it? Yeah? Okay. Question? No? Okay. Right. Now I need to make my table a little bit bigger here. What I'm going to put down the bottom, let me just make a bit more space. Well, actually, you know what? I'll just write it here. Here I'll have the mean x. What does that mean? What's mean x? Average x. So let's all get the average here. Average, bracket, all the x's, close bracket. And then mean y equals average, bracket, all the y's, bracket. Okay. So I want the average of the two, please.
The average value is not what we used to calculate the uncertainty.
Or it'll be part of the JAF, but what we're going to do is calculate the uncertainty very, very accurately, and we'll need to use the averages in Excel and other things too. Previously we just used the averages in the formula I gave you, but Excel can calculate it much more exactly than we can. Okay, can I go on now? Yeah. So if I go back to this graph, up the top here. Whoop. Now, let me call this point here, for example, x1, comma y1. So what I'm going to do is I'm going to look very closely at this point as an example. So if I zoom in, here's the line, and here's the point. This is the point x1, y1, and this is the line y equals mx plus c. If I put, look up please, look. If I put in here x1, y equals mx1 plus c, what do I get for y? Well, if I put in x1, I don't get y1, I get this point here, y. Can you see that? Because this is the line, and I'm putting my point in the line, so I get this value here. So this distance here is like the uncertainty. It's the difference between what you expect and what you got. So if I go here, you see all these distances here, all these little distances. You want them to be small, okay? The smaller the better. So how can we calculate this distance? Well, it would just be y minus y1. But sometimes the point might be above the line. So if you use this formula, you get a minus, and you don't want a minus. Distance should be positive. So the way we fix that is we use what we learned in maths, the absolute. Okay, so here's the formula for you. This here, EI, is absolute y minus yi. This here is telling us like a type of error, how far the point is from the line. Can you make note of that? And the name of this error is called residual error. You need this vocabulary now. Okay, can I go back to Excel? Yep. Okay, so to be clear, this x here is our data, and then this y here is our data, and what I'm going to do next is y, not data, y on the line. So the formula for the line is equals m. Here's m here. But please don't forget to put $2 signs. Remember in semester 1 I showed you this. We need the dollar signs to keep it constant. So it's m times x plus c. And again, don't forget the dollar signs on the c. I'll leave the formula there for you.
Is that B1?
No, B dollar sign. It's dollar sign B dollar sign 14 times A2 plus dollar B dollar 15.
Do you have to type in the B or do you have to click?
Either is fine. If you have it in the exact same format as me, you can just type it. You don't have any extra spaces or anything?
No.
Then try typing it. Can I go on? Do you have that done? Did you manage to get the same number? Yeah. Who can tell me what this number represents? Well, can anybody tell me? Huh?
No.
No? No. Well, just think back here. What this number represents would be this point on the line. In other words, it's where the point should be versus where it is in your data. So the 0.85 is like this point, and if you look here, what number did we get for y? We got 1. What should it have been? 0.85. So is this point above or below the line? This point here, is it above or below the line? Come on, don't be shy. Above. Are we reaching maximum difficulty now? Look, here's my line. Look, here's my line. That 0.85 is where we think the point should be on the line. 1 is what we got in the experiment, which is up higher than 0.85. Yes? So our point is above the line. Now I don't have my graph open anymore. Do you still have your graph open?
No.
Some do? So look at the first point. Is it above or below the line? It's kind of hard to tell, but it is clearly above, is it? Does anyone else have the graph still? It's above, which is what I'm saying. Is it a little above or a lot above? A little. How much? 0.15. That's the difference between the two numbers, isn't it? 0.15. So let's calculate that. What's the name of this error? The difference between the data and the line. What's that error called? Residual. So I'll just write RESY. Or I'll just write, or residual y. Now watch the formula, please, look. Equals ABS. ABS means the lines we did in math class, the absolute, the modulus. ABS, this number minus this number, that should be 0.15, and it is. Okay, so I want you to get these two, please. Tell me when you have them. Do you have it? Residual y? Yeah? Can I go on? Yes? So what I'm going to do now is I'm going to copy these formulas down to do it for all the points. So I'll just copy them down. Now quickly look here. Which is the biggest residual? This one here. Now if you look at your graph, is there a point in the middle of the graph that is very far from the line? Yeah, there is. That is the one with the biggest residual. Okay. Can I go on? Do you have that table complete? I copied them down. I'll wait for you, it's okay. Okay, can I go on now? Do you have that done? Yeah. Okay, what I'm going to calculate now is the mean residual for y. In other words, the average of these numbers here. Average of these numbers here. Whoops. These numbers. Typed it in wrong. Average bracket these numbers here. Does anybody want to, well, once you have it done, does anybody want to tell me what they think this number signifies, what it means, what it's important for? Yes? Yeah, on average, how off the points are vertically. So do you want this number to be big or small? You want it to be small, don't you? Do you have the average calculated? Dana, soon? Over there, you have that? Tanish? Yep, okay. Now, this is our first uncertainty calculation. The great thing is, once you've done that mean residual of y, it's very easy now to get the uncertainty. I'll just write once. The uncertainty of y is just twice that number you calculated. It's as simple as that. So we've done all the hard work. The uncertainty is twice that number you just calculated. Twice the last number you got.
You mean the 17?
The 0.36, the mean residual, double that number. You install this program, Joshua? Are you using my hacked version of Moodle, or you got something at your own? Oh, sorry, you mean you're using the legitimate version you acquired? Okay, do you all have that number down? Yeah? So look what you have. You've calculated the uncertainty in the y value. So what was your average y value? 9.72. And you have an uncertainty in the y. But this actually is no good for you, because if you think back to Ohm's law experiment, what do you put on the y-axis? What goes on the y-axis in Ohm's law? No. Current. And what goes on the x-axis? Voltage. Do you want the current and voltage? No. What do you want? Come on, please, look at me. Look at me. In Ohm's law, what are you trying to find? The resistance, which is represented by finding the slope on the graph. So you don't want the uncertainty of x, you don't want the uncertainty of y, you want the uncertainty of the slope calculation. So before we get to that, we need to calculate the uncertainty in x now. And that's a little bit more difficult. Not much, but just a little bit. Because if I go back here, look, my formula I need to use is this. problem. We don't have a formula for x. But here's the solution. We can easily make one. If I go back to my formula, y equals mx plus c. Do we know the m? Yes. And do we know the c? Yes. I can rewrite this as y minus c over m equals x. Yes? So if I put that in here, I get this formula. Residual, this one is in the x now, so I'll just write an x here. Residual in the x equals absolute. So here, y minus c over m minus xi. And just to be clear, this y here, this is the point on the line. So likewise here, this is the one on the line. In other words, just put the little I here. Now that might seem a little bit messy to do, but there is another way to do it. So I'll show you the other way, and then we can see which is better for us. Can I go? Are we still looking up here? I don't understand why there's so many clicking, because right now it's not clicking time, it's taking notes time.
Yeah, I'm writing.
That's fine, okay. Do you remember here? The residual measures this distance here, yes? So the x residual measures the horizontal distances. Okay? There is another way to calculate it. What about if I do this? If I swap my x and my y, and then I draw my line.
The values.
Yeah, literally swap the values. If I calculate the y residuals, then it actually is going to be the same as calculating this one here with x and y and the points here. So which do you want to do? Do you want to use the formula I gave you a minute ago, or do you want to swap the x and the y and then get the residual the same way? What do you think? Yes, what do you think? Formula? Any other opinions? Or don't care is a fine option? Don't care? Really? No, really, this is really me asking you. Do you care which of the two? So which of the two would you prefer? Okay, so we'll go with the formula then, okay? So do you have the formula written down? Where's my formula gone? Ah! You have this formula? Okay, just before I use the formula, I want to clean it up a little bit. So let me just clean it a little bit. This is yi over m minus c over m minus xi. Okay, so this is the one I'll use. Can you read this back to me in a moment? I want to type it in. Can I type it in now? Do you have it written down? Yeah, okay. So, here is residual in the x. Okay. Equals absolute. Right, what's the first part of the formula?
Y minus n.
Now, do I have an I on it?
Sorry?
The first part of the formula is yi over n. Did you write this down?
Yeah.
Right. So what's first? yi, the first point,
Y-I.
yep,
O-M.
over the slope.
Oh yeah.
Slope, yes. Now don't forget the dollar signs. Okay, what's next?
C-O-M.
Plus or minus?
Minus.
Intercept, don't forget the dollar signs. Over over n, yeah? And don't forget the dollar signs. Okay, and finally,
minus x1.
minus the x point. Minus the x point. So if you look at your graph, the horizontal distance between the point and the line for the first one should be really, really small, horizontally. So if somebody still has the graph open, I'd like to see it. Do you have it already, Andy? Yeah, so I mean, there's almost no horizontal distance between the point and the line. This one here looks like it could be like 0.6 of the distance. Okay, do you have that? Or are you working on it? Yeah. Now, if I look at your point, the people with the graph, can you listen? Look at point number 3 on the graph and tell me, horizontally, how far do you think the point is from the line? And if I look at this, what would you say? About what's the difference? 0.5 in the distance, maybe? Horizontally.
Yeah.
What do you think, Dana, soon? Dana, soon? You know what I'm asking you? Look at your graph. Look at point number 3 on the graph. You see it? What's the distance, in your opinion, between the point and the line on the x direction, x horizontally? About 0.3 maybe, yeah? Yeah? I think maybe more than 0.2. So let's see what we get when we calculate it. If I copy it down, oh, I guess we were way over. Yeah, you're right, 0.2. Did you know that, or did you guess it? Oh, you saw it, alright. 0.2. Now we can calculate the uncertainty in the y. The mean residual first in the x. That is average all of these points. And now the uncertainty of x equals twice the last number. I'll zoom. I'll try and squeeze this in a bit more. No, that's as good as it's going to get. Do you have that 2 calculations done now for me? Do you have that, Jeb? So look here, which one is more certain, the x or the y? Which one has the bigger error? Which one has more error, the x or the y measurement? The y measurement has more uncertainty, doesn't it? 0.72? But wait, hang on. Wait, listen. I said which one has more uncertainty, the x and the y? Well, we don't really know because these have units, remember? One could be voltage and one could be amps. So what we could do is we could make it a percentage. We could take the uncertainties and divide them by the means. So if you look here, the average y, see here, is twice as big as the average x. and the uncertainty of y is about twice as big. So although it looks like this is more uncertain, I don't think it is. I think they're about the same. Now if you want, you can make these percentages, and you can see, I'm not going to do that now because that's a little bit beyond what I expect you to do, but I'm giving you little ideas. If you want to get higher marks, these are the types of things you could include as extras. What makes the A's instead of the B's. Okay? Anyways, we'll go on. Okay. So, to quickly recap what we have so far, we have our points, we have our line, I know what the uncertainty in the x measurements are, I know the uncertainty in the y measurements, what that is, so I got this, I also know what the average x is, and I also know what the average y is. And I also know what the m is, I also know what the c is. But I don't know what the uncertainty for the m is. Because remember, I'm trying to find the m, but I would like to know what the uncertainty is for it. So how do I calculate that? Well, the good news is, when I have this number, and when I have this number, I can calculate it. This is how. The uncertainty of m equals, now I need brackets here. Well, actually before I do that, let me just do a calculation first. Ratio of uncertainty. So this is the uncertainty of y divided by the uncertainty of x. That's what word ratio means, as you know. So uncertainty for y divided by uncertainty for x. Before I type it in, what number should this be roughly? Uncertainty for y divided by uncertainty for x. Roughly, what should it be? 2, yeah. And it's nearly 2. Okay, now I can get uncertainty of m. And the uncertainty of m is equal to this ratio divided by how many points you have. I don't know how many I have. I'll have to count them. So let me just count how many points I have. I don't know. You can count them by hand. I just got Excel to count them. How many points is it? Is it 11? It's 11. Yeah, so you can just do ratio divided by 11. Yes. First, I want you to do it now.
Yeah.
So get calculating. Come on. Have you got that uncertainty for m? Yep. And do you have the value of m here? Okay, so far this is our result. We have what does m equal, please? 1.97 plus or minus, or multiply uncertainty for m. 0.18. Well, give me 3 decimal places.
0.1796.
Yeah? No? Yeah. So this is good. We now have a calculation for the slope, and we have an uncertainty for our estimation of the slope. But if we go back to Ohm's law as an example, we have V equals I or, but V is on the x-axis, so really we have I equals 1 over or V. So we don't want to know what the m is, we want to know what 1 over m is. But I got the uncertainty for m. What's the uncertainty for 1 over m? Okay, well the uncertainty for 1 over m if you think about it, if I go back here, if I have m to the power of minus 1, what's the formula for uncertainty when you have a formula? It's square root minus 1 squared multiplied by the uncertainty. Sorry, I'll write the formula out fully. Okay. So we have or equals 1 over m. I'm sorry, I'm going a bit too fast, I know. Do you see what I'm saying about or equals 1 over m? Yeah? So we want the uncertainty for or, and we know the uncertainty for m. So let's see what we get. The uncertainty for or divided by the average for or the estimation for or, equals square root minus 1 squared, and then we have the uncertainty for m divided by the value for m. Okay, so we have uncertainty for or equals or, and then this goes, and then we have square root, oh sorry, it's a square here, so that goes as well. Uncertainty for m over m here. What did I say or equals? 1 over m. So then this becomes 1 over m times uncertainty for m over m. So now I've got the uncertainty for or. It's the uncertainty for the slope, which I know, divided by the value of the slope squared. What's this number here? 0.180 over 1.99, what was it? 97? 976 squared. So this is what you need to do if you don't want the slope and instead you want to calculate 1 over the slope. Now I was very kind to you because I picked a 1 ohm resistor, it means that this value here should be approximately 1. So in fact the uncertainty for the slope and the uncertainty for 1 over the slope is roughly the same number anyways, okay? So it's just to be a little bit more accurate. So just be careful. You can calculate the uncertainty of the slope, but if you want the uncertainty of 1 over the slope, you have to do this extra calculation at the end, which you need to do for lab 3.
Is this recorded?
Hamish, answer him. Okay, there's, I think, just one last thing to show you, and I want to show you it. It's something on the graph, okay? So I'll just go back to the graph, and then we'll look at the answers from the homework then. Okay. So, hey, just to finish, I'll just write in here uncertainty of 1 over m. Well, let me write in here the 1 over m equals, that is 1 over m here, and then the uncertainty of 1 over m, that equals, what was my formula? It was uncertainty in m divided by m squared. Okay, so that equals uncertainty in m divided by m squared. So I need to have, oops, star P14. So a really small number here, 0.046. So we are quite accurate in our prediction or our estimation of 1 over m. Last thing to show you here is something again with the graph. So I just need to draw the graph again. Can I go up? Yep. So very quickly the graph. Insert, chart, scatter, next, no legend, don't forget X and Y axis, title with a subtitle, with an X, with a Y, finish, and then here, insert trend line. The last thing to show you is here, insert Y error bars. No, that's
It's like the positive or negative or positive.
yeah, well hang on, let me just see, why is that all messed up? Insert Y error bars. No, sorry, that's standard deviation, standard error. Okay. There we go. So I'll just show you that again. Now it might be different for yours, but what I did was, I picked insert error bars, and very importantly, you want to pick error here. Insert error bars, standard error, and you get that. Oops. Now I know on some programs, I can't see it on mine, but on some programs you can put in the X error, but X error bars as well. If you have an option for the X, can you please include the X as well? I can't include the X right now. I can't.
Say, like, if I include it, like, say, I had to choose the positive or negative.
Yeah, but you didn't pick standard error, you picked standard deviation.
No,
Click here. No. There must be some option somewhere here type. Can you go back to the start and show me how you pick this? So,
no, I just clicking the graph.
I don't know, but undo what you did and start this piece from the beginning. I want to see what you did. Yeah, undo. There, okay, so what did you do? No, get rid of this box, or is that box always there? Alright. Yeah. And then, now, the error bars. Yeah, now click that drop down.
Yeah, I have to.
Positive and negative.
Yeah.
Click it.
Can use it.
Do you have more options here?
And that
Use, there, standard error. No, error. There, now do the same for the other direction. Have you got them in? And you have a Y as well, X and Y? Exactly this. Do you have this?
yeah.
You have it? Good. Do you have this array? The X and the Y? Can you see?
This becomes easier than it's
Yes? Good. Yes.
No, how do you
Hang on, we'll help you in a second. Listen, what these bars represent is what you might call, what these bars represent is the uncertainty. What you're saying is the data point is in blue, but we know it's not exactly there, it's somewhere there. We're not 100% sure where it is because there's an error. These error bars tell you like the location the point could be if you did the experiment again. Okay? Now look, imagine, look here. Imagine if I did this experiment again, so maybe Dana and Soon, they did the experiment, they got these blue points. And then Daniel and Tanis, you did the experiment, and when you did it, your point was a little bit lower, and then the next point was a little bit higher, and so on. Will you two get the same slope? No, because if I move the point a little bit, then the line moves a little bit. Yeah? So this is why we have uncertainty in the slope. because the location of the point is not exactly known. So yes, you should have these lines in on your graph to illustrate graphically the uncertainty. These demonstrate, these show the uncertainty on the graph. Yeah? Okay, now,
So, equation, like,
if you have an option to show the equation, you should. Yes.
So how many graphs do you want in two or one?
I want one graph, but I have no problem if you want to split the graph into two graphs, one with the bars and one without the bar, or one with the line and one without the line. But basically, everything I've shown you today, I want it on a graph. And you can put it all on one graph, unless it becomes too cluttered and unclear, then you must decide to split it. Okay? So I know there's a lot there, but the good thing is this lab isn't due until after the break, right? So you have time to do all this. And again, I remind you, I don't... Now, please don't do this. I told the students last year not to do this, and one of them did it anyways. So don't do what I'm about to say. Don't just copy the Excel file and paste it into your Word document. Right? So I say that again. Don't copy and paste the Excel into the Word document. I don't want that. Somebody last year did it and I gave them 0 for it, okay? I want you to explain in your report each of these calculations. So you would say, to calculate the slope, you use the slope function in Excel. And here is the format for the slope function. Equals slope bracket, close bracket, okay? So you need to explain to the reader how they can reproduce your numbers. This is important in statistics.
So you want us to print the screen on Mark?
Oh. Now hang on, just think for a moment. If I said I don't want copy and paste Excel, do you think that means I would like the screen copied and pasted into the Word?
No, not copy and paste it. Print, just print the screen. Print.
He means the attachment
Print the
and
Excel.
the
I'm glad someone just sent it to you. I want the Excel file. Yes, you can put it as the appendix at the back or print it, but it's not necessary to do. It's not necessary. I'm not expecting it, but if you want to put it at the back as an appendix, you can. Unlike the maths, I think I gave you a 10% penalty if you didn't put the appendix at the back. You can talk to Ali about that. But for physics, I'm not expecting it, but you know, every little bit extra you do will give you more marks. Yes?
So in the end, when we're done explaining like how exactly to do this,
Yes.
the graph though, the result of
Yes.
can we like put that in the
What do you mean the result of the graph? Do you mean the answer at the end?
like because we're gonna have to include the graph, right?
Yes, oh definitely.
And this will be the graph that we're gonna have to include.
Oh yes,
So
yes.
we can only include the graph,
Yes.
then say how we did the graph and explain.
Yes, you're right, yes. So I need the graph,
Yes.
like this, and an explanation of all the calculations
Then
involved.
we'll do the calculation.
Oh yes. How to do the calculations and get this graph, yes. Yeah. Okay. Any other questions? Yeah.
Sorry, is it possible that after we explain and include the graph, we say in the end, when you open Excel, it should look something like this, and then show like maybe a...
No, not necessary. You can just say, I've attached in an appendix my Excel work, if you want. Yeah. It's just an appendix if you want it. You don't need to really mention it in the report. Just put it at the back if you want. Okay, I'm going to stop this recording and start the recording. I'm going to go through the answers of the last page I gave you. Yes, there's time to do it. So can someone just give me a copy of it, please? Dana, did you get yours?
This one.
Give it to me, please.
And it's like well,
Thank you. You know what? Give me a calculator as well. A nice calculator.
Yeah.
It's Casio 991.
I think we should do